Hi everyone, I'm Pelumi, the project manager for Group 3, also known as Mission Control. My group members are Aksh, Fariha, Gilbert, Tolani, and Quill. This is assignment 7, which is about project crashing. This assignment involved refining our original budget to include hiring and firing costs for both skilled and unskilled workers under the normal schedule as well as a crash schedule. Doing this increased the total project cost and it resulted in a difference of about $21,723 between the budget of the two schedules. Now, a brief explanation of project crashing. It's a technique that's used in project management to reduce the duration of a project, and doing this requires additional resources, for example, labor. The timeline of our project reduced from 125 days to 95 days after crashing, which is a difference of 30 days. It's easier to represent this on an activity on arc network diagram, so we converted the original activity on node network diagram to this. Before calculating the hiring and firing costs, we revised our previous labor cost calculations to correct some errors, and this adjustment resulted in an updated total labor cost of about $195,507. For the hiring and firing costs, our team discussed various methods based on our research, and we finally decided on the following approach. So we have a flat rate for hiring costs, which is $1,000 per skilled worker and $500 per unskilled worker. For the firing costs, we calculated those as 30% of the total hours worked, and we applied this method to each system individually, considering the specific number of hours required for each. So here at the bottom shows the formula that we used. Because of the method chosen to calculate the firing costs, it's expected to be the same under the normal and the crash schedule because the total number of man hours remains the same for the entire project. So these are the steps that we took to crash our process. To begin, we simplified the nodes once again to create a simpler network diagram. We then converted the activity on node representation into an activity on arc network diagram to improve clarity and make things easier to analyze. The next thing we did was determine the crash durations for activities that could be shortened. So since some activities can't be crashed, we focused on the ones that could. Our primary focus was on critical path activities because reducing non-critical activities would not impact the overall project duration. To minimize our costs, we prioritized crashing the least expensive activities first, and the cost to crash each activity was calculated as the difference between the normal and the crash schedule costs for that specific activity. Those values are summarized later in the presentation. So this approach gave a 30-day reduction in the project duration and came out to a total crashing cost of $14,500. It's important to mention the mythical man-month effect. So under the crash schedule, labor costs increase due to the need for additional manpower. However, hiring more people doesn't necessarily mean that the duration of each activity would decrease proportionally because of factors like coordination challenges and training time. This table shows each activity, the predecessors, their durations, and the costs under the normal and the crash schedule. The ones in red are the critical activities. The cost to crash in dollars per day is the difference between the costs under the two schedules. And as we explained in the methodology, we focused on crashing the projects in the critical path, starting with the one with the least cost. The first activity we crashed was the one based on the electrical system, since it's the cheapest, followed by the hull and deck system, then the sanitation, then fresh water, and finally the sea trial activity. To determine the total crashing cost, we converted the per day costs into total costs by multiplying them by the number of days that each activity was crashed. So summing these values across all the crash activities gave a total crashing cost of approximately $14,500. So this is the original activity on arc representation of the project network diagram. As you can see, this is the one with the no crashing, and the solid black lines represent the activity arcs. The broken arrows are for dummy activities which don't take up any resources or time, and they're just used to show the dependencies between the tasks. And lastly, the red arrows show the critical path and the activities on it. As we can see below, the length of the critical path indicated with red arrows is 125 days. This is the network diagram after crashing, and we can see that the total duration has been reduced from 125 days in the previous slide to 95 days. On this slide, we can see the cost differences between the two projects. The labor cost includes each hiring and firing costs. The supplies refer to the materials used in the construction of the boat, and this cost remains the same under both schedules. Finally, the indirect cost is calculated as 10% of the labor cost, and this brings the total cost of the original project to $477,160, and for the crash project is $498,883. This slide summarizes the key differences between the two project schedules. As shown previously, the total cost is approximately $477,000 for the original project and $499,000 approximately for the crash project. The hiring cost increases from $29,000 in the original schedule to $43,500 in the crash schedule. The firing cost remains the same for both schedules because it was calculated based on the total number of hours worked, and this did not change between the two. Lastly, the project timeline is reduced from 125 days under the regular schedule to 95 days with crashing. So to conclude, we can see that project crashing is effective in reducing the project timeline, but then it comes at the expense of additional resources and higher labor costs, as reflected in these differences. Thank you for listening.